Hello, this is another biographical video, this time on Emmy Noether. Now, this video won't be as long as it should be if I was doing a maths video, um, because Emmy Noether was just, well, yeah, I mean, she was epic at maths, and most of it I don't understand and is way beyond this series of videos. So don't take the length of this video as being a some kind of signal to her impact, because she had a very great impact on maths and science more in general. So she was a German mathematician. You can see her born towards the end of the 19th century, and then working during the early 20th century. She was the daughter of Max Noether. He was also a mathematician. But as his daughter, she faced the usual obstacles that women faced back then. They weren't allowed to study for degrees, and have, for the most part, jobs at universities. But she was so good at mathematics that she was brought to the University of Göttingen, probably not pronounced that way, but in central Germany, by David Hilbert, another highly esteemed mathematician, who again would get a video if I was doing videos on mathematics. And he was brought there because she was an expert in what's called invariant theory, regarding things that aren't changing. And they needed help at the university to understand general relativity. This is the era of Einstein, and there were a lot of things that needed to be sorted out in relativity. It was a new and groundbreaking theory, and one of those things is there seemed to be possibly a paradox at the heart of it, in that it looks as though gravitational energy itself could gravitate, and then you've got this snowballing up of gravitational energy, which would then violate conservation of energy. Now, Noether was working on this, and she published her theorem, Noether's theorem, in 1918. And it not only solved this problem, it showed that every time there's some kind of major symmetry in the universe, this then combines with a conservation law. And this is why she's so important in physics, because we're always talking about these conservation laws, conservation of energy, momentum, and angular momentum. And it's Noether who gave a mathematical foundation to these laws in physics. So she showed that if you've got uniformity of time across the universe, then you've got conservation of energy. If you've got uniformity of space and distance, then you've got conservation of linear momentum. And if you've got uniformity of space and direction, then you necessarily have conservation of angular momentum. So she managed to show that these symmetries in the universe, where we see that distance, direction, and time are uniform across the universe, well, if that is the case, then necessarily you have conservation of energy, momentum, and angular momentum. You can't have one without the other. So she gave this foundation to these conservation laws that didn't exist before, that had just looked like these they're just empirical findings or whatever. Well, she gave this strong mathematical foundation to all of that. I mean, she did loads of other groundbreaking maths as well, which, I mean, to be honest, I don't know it, I don't understand it, so I'm not going to talk about it here. If you get much more advanced in your mathematics, then that'll be something that you'll end up knowing much more about when you're at university. But interestingly, from a physicist point of view, Noether's theorem, in order to show these conservation laws and the mathematical foundation, although they are beyond the level of this series of videos, they're not that complicated by today's standards, and you can cover them at undergraduate level at university. That's not to diminish her achievement. I mean, there's still astonishing insights, and a lot of her other mathematical discoveries are like, well, mind-blowing stuff. But yeah, these aren't completely out of reach to your undergrad physicist. So yeah, that's Emmy Noether. I mean, groundbreaking. Sadly, not that well known, but had an epic impact on mathematics and physics within, well, the last 100 years.